Welcome to our channel. Don't forget to join and subscribe for more insightful content. Today, we'll dive deep into understanding deadlocks in Java. Deadlock in Java refers to a situation where two or more threads are blocked forever, each waiting for the other to release a resource they need to proceed. This can lead to a complete halt in program execution, as the involved threads cannot continue. Now let us understand how deadlock occurs. First, mutual exclusion. At least one resource is held in a non-shareable mode. Only one thread can use the resource at any given time. Second, hold and wait. A thread holding at least one resource is waiting to acquire additional resources that are currently being held by other threads. Third, no preemption. Resources cannot be forcibly taken from a thread. They must be voluntarily released. Fourth, circular wait. A set of threads are waiting for each other in a circular chain. Now let us understand symptoms of deadlock condition. The first way is threads hanging. Threads remain in a blocked state indefinitely. This shows a deadlock situation. Second way to identify is performance issues. The application may slow down significantly as it waits for resources that are never released. Another symptom is resource utilization. CPU and memory resources may be underutilized since some threads are blocked. Okay, now let us understand detection of deadlock. First way is through resource allocation graph. This graph illustrates the allocation and request of resources. If a cycle is detected in the graph, a deadlock is present. Second way is thread dumps. In a Java application, generating a thread dump can help visualize which threads are blocked and what resources. Third way is deadlock detection algorithms. Some operating systems and runtime environments implement algorithms that periodically check for deadlock conditions. So, friends, these are some of the ways by which you can identify the potential deadlock condition. Now let us understand resolution of deadlock. First way is by killing processes, terminating one or more threads involved in the deadlock, allowing others to continue. Second step is resource preemption, forcing one thread to release a resource so that another can proceed. This approach can be complex and requires careful consideration of the implications. Third step could be manual intervention. In some systems, administrators may need to intervene to resolve deadlocks. Now we will understand prevention of deadlock. The first preventive action you can take is lock ordering. Establish a global order for acquiring locks and ensure all threads follow this order. Second one could be timeouts. Implement timeouts on lock acquisitions. If a thread cannot acquire a lock within a specified time, it releases all currently held locks and retries after a random backoff period. Third option could be single lock acquisition. Instead of holding multiple locks simultaneously, try to limit the scope of locks. Acquire one lock at a time when possible. And finally, the last but not least, avoid hold and wait. Require threads to request all the resources they will need at once, rather than holding on to some while waiting for others. Now, to summarize, deadlock is a significant concern in multi-threaded programming, particularly in environments like Java, where threads frequently compete for shared resources. Understanding how deadlock occurs, how to detect it, and how to prevent it is essential for building robust and efficient applications. By applying proper synchronization techniques and resource management strategies, you can significantly reduce the risk of deadlock in your applications. Now we will learn some of related concept of deadlock situation. The very first is sleep method. The sleep method in Java is a static method defined in the thread class that allows a thread to temporarily pause its execution for a specified duration. When a thread calls thread.sleep, it transitions from the running state to the waiting state. During this time, it releases any locks it holds, allowing other threads to execute. After the specified duration, the thread becomes ready again, waiting for the CPU to schedule it for execution. Common use cases are simulating delays. You can use sleep to simulate time delays in applications, such as waiting for user input or simulating processing time. Second use case could be polling mechanisms. In scenarios where a thread needs to periodically check a condition, like a status update, sleep can be used to avoid busy waiting. Now the third use case is rate limiting. When you need to limit the execution rate of a thread, sleep can help control how often a particular action is performed. Okay, now let's understand important considerations for sleep method. First is precision. The actual sleep time may be longer than specified due to system scheduling. The precision of sleep is not guaranteed. Second one is interrupt handling. Always handle the interrupted exception to ensure that your thread can respond appropriately if it is interrupted during sleep. Third is thread management. Overusing sleep can lead to inefficiencies. Okay, dear. Now another important method is wait. Let us understand that. The wait method in Java is used for inter-thread communication, allowing a thread to pause its execution until another thread notifies it that it can continue. It is a vital part of the Java concurrency model, typically used in conjunction with the notify or notify all methods. Key points about wait are: first, belongs to object class. The wait method is defined in the object class, meaning it can be called on any object. This is because every object in Java has a monitor, lock. Second, releases the lock. When a thread calls wait, it releases the intrinsic lock, monitor. It holds on that object and enters the waiting state. This allows other threads to acquire the lock. Third is notification. The waiting thread remains in the waiting state until it is notified by another thread that it can proceed. This is done through the notify or notify all methods. And fourth is, it must be called from synchronized context. You must call wait from a synchronized block or method. If called from outside a synchronized context, it will throw an illegal monitor state exception. Some of important considerations are: first, interruption. If a thread waiting on wait is interrupted, it will throw an interrupted exception. This should be handled properly to ensure thread responsiveness. Second, notify mechanism. If multiple threads are waiting on the same object, the notify method will wake only one waiting thread, while notify all will wake all waiting threads. Thanks for watching. If you found this video helpful, please subscribe to our channel for more Java tutorials and tips. Your support helps us create more valuable content.